Provide the sample output from one of the test set on the fold, one fold for the classification. So here is the executing. So this is the test instance and this is the class, basically predicted class, and same for the entire test set for the one fold. Going to the next, provide the sample output from one of the test set on the regression for the one fold. So here is the output, all the tests and test instance, and this is the predicted output for all this thing, all the instances for the fold. Show the sample classification tree without pruning. So here is the thing. So this is the classification tree, each level node and the feature at everywhere. Um, so all the prune indicator you will see as a false. Next, provide the classification tree with pruning. Okay, so here we can select some of the indicator will be a true. So here the prune indicator is a true. So it's a with pruning, and this is the rest is the classification tree. Move the next sample regression tree without early stopping. So for the without early stopping, I just keep them early flag is 0.01, um, and then running it over here. So this is the tree which is very detailed. All the samples are the one over here. Move the next. With early stopping. So early stopping MSC I have kept up to 1500 running it. Now we have compared to very smaller tree compared to the previous one, and samples are pretty big size as well, compared to all the one compared to previously. Calculation of the information gain and the gain ratio. So here is the like at the node level all the calculation of entropy, information gain, split criteria, entropy for the node, information gain calculation as well. So it's a pretty detailed one for each calculation, um, for information in gain ratio. uh, and over here, mean square. Next is a mean square for the regression. So here is like a, for the split point, for the positive one, here is the split point MSC, and at last the predicted one, the MSC for the predicted values. So otherwise, the MSC at the intermediate level. Next, decision made to prune the subtree. So here we can see the accuracy before pruning is 90%, after pruning is 90.6%. So its decision is made to prune that tree at this node and at this value of the node, the feature and the value of that. So this we can see all these things pruned out. Decision being made to stop the growing. So here is my early stopping. So decision we will see like at the MSC is 778, which is less than 1500. So it's basically cut off it stopping over here. So in that way, all these MSCs are less than the early stop. So that's the where the decision is made to stop it. Example of the traversal, tree traversal. So this is the test set, and this is where uh, it is deciding based on the value of the feature and the attribute, and then going to the next features and attribute, and at last the predicted output of the is ACC, which is matching with this over here, and this is with the traversing for the classification. Next, regression and the prediction made at the leaf node. So over here this is the actual value and instance, and the decision is being made over here to go right or left based on the value at the node. So moving left over here, moving right again left over here, and this is the predicted value. Now the average performance of the five-fold cross validation. So I'm just running it and see like if we can get that done. I'm pausing it for some time. Okay, the output is there now, so we can see like this is a five-fold accuracy for pruned and unpruned, and the average accuracy for the unpruned is 91.11, while for the pruned accuracy is 91.650. Now moving on to the next is the average performance over the five-fold on the regression data set with and without early stopping. So I will run it now, and then again the execution is started, and I will just stop pause it until the execution is complete. Okay, the execution is complete now, and we have the MSC for without and with early stopping for each fold, and this is the average accuracy for all the folds, and with early stopping and without early stopping. Yeah, that's pretty much. Thank you very much.